and maybe we get something out of that. All right. So last time we talked about exponential functions, yes? And we said exponential function in general, f of x out of the form of, I just put a to the power x. So we took a simple equation or a simple function, and we talked about that. We talked about all the kind of graphs that you can get from that exponential function. Yeah? Today we're going to talk a little bit about application of those functions. Where do they apply? First application, or most application for exponential function are in exponential growth or decay. Okay? And those functions come in the form of, say, f of t equal y0 e to the power kt, or f of t equal a b to the power t. Both of these equations are exactly the same. Yes? Now, there are a few things about those equations. Y0 and A, let me write them there down. Y0 and A represent initial values. Yes, Y0 and A represent initial values. So if we're talking about a particular equations, so those initial values mean at time t equals 0. Yes? Because when t equal to 0, what happens? This whole term becomes exponent 0, right? And e to the power 0, we said it's 1. Yeah? And again, if we have b to the power 0 is also 1, and therefore f of t will be a in this case, and f of t will be y0 in this case. So those two values represent the initial values of the equation that you're talking about. Okay? Now, e to the k and b, e to the k and b are both the same. Yes, they are the same value. Okay? In any particular equation. And they represent the rate at which we have the changes happen. Whether we're talking about exponential or whether we're talking about decay. Yeah? If k is greater than 0, in this equation, if k is greater than 0, and in this equation, if b greater than 1, in that equation, in that form, we're talking about b greater than 1, yes? And in this form, we're talking about k greater than 0. Both of these represent exponential growth. Exponential growth. Yes, that means the values are increasing exponentially. So another way, graphs look like this. They're getting bigger and bigger and bigger as time goes by. Yeah, this is exactly what we talked about last time. If k is negative or b is between 0 and 1. Isn't that what we talked about it last time? Between 0 and 1 for the equation? Yes? What do I have? This scenario represent exponential decay. Decay means the amount is diminishing or getting smaller and smaller as time go by. So the graph of this kind of equation will look something similar like that. Yeah. So those are basic ideas about exponential function and exponential growth or decay. Okay? So let's go ahead and take some examples for which we can use those equations. Okay? Let's take a look at so those basically are two different ways of writing the equation. It says total debt. The amount of debt across sectors, across all sectors, in billions of dollars can be approximated by the exponential function. So we're given a function that represents the debt. And that equation says f of t equal y0 e to the 0.038 t. And this function f of t is the debt in billions of dollars. Yes? It says where t is the time in years, and t equals 0 correspond to the year 1970. So year 1970 means t equals 0. So another way, we started using, or this formula was set up and used in basically since 1970, let's say. Yes? So this formula is valid for all values for t from 1970. It says if the amount of total debt was, so the amount was, amount or debt in 1970 were, and let's say what they were. $1,946 billion. So in 1970, the debt were $1,946 billion. The question is, find the total amount in the year 2017. So find total in the year 2017. So we need to figure out how much the debt was in the year 2017 based on the given information. So in order to figure out the debt, we need a formula. But the formula is given, and that's the formula. The formula is missing one value in order for it to be usable. And that value is y0. Yes? And I just explained y0 in this case would represent the debt at year 0. Yes? So how much was the debt in year 0? It was 1,946 billion. Why? Because it starts in when? In 1970, and it says year 1970 means t equal 0. So now I can rewrite this formula by saying, well then f of t equal 1946 e or 0.038 times t. Now this formula is complete. All I need is you just give me a time and I figure out what the debt is going to be at that particular time. Yes? So how do I find out what was the debt in 2017? So we need to figure out what T is. Yes? So what is T in 2017? So T in 2017 equal. What does it equal to? How do I find the time that has passed up to 2017? So when did we start counting? 1970. So I need to know how many years passed from 1970 till 2017. So how do I find that? We can just simply subtract them, right? So that's going to be 2017 minus 1970, and that should give me 47 years. So that means we need to figure out the debt 47 years after that formula was made. Yeah. To do that, we just simply replace t by 47. So that's going to equal to, so f of 47 equal 1946 e 0.038 times 47. Do you think is it going to be more or less than that amount? Less? What do you think? And you said more, and you would say less. So 3 less versus 1 more. Let's see. What did we say about what K represent? This is K. Yes? It represents, if it's positive, it represents what? Growth. And growth means what? Increases. So what should I expect? More. Yes? Why? Because this is growth. The debt is growing based on the formula given. If this happened to be negative, then yes, I would expect less debt as time goes by. But the formula stated that K is positive, so therefore the debt is going to be growing as time goes by. Yes. And the answer is 96,000. So that should give me 96,233 billion. Or so 96.233 trillion. So this is the amount in 2017 based on the formula that was represented in that. Yes? So how do I find the amount in 2021? How would I find that? First, we need to figure out what T is. And then T would be 2021 minus 1970. That should give me 51. Knowing what T is, then I can substitute T in here into the equation. Yeah? And what do you think that amount? Is it going to be more than 96 trillion or less? More. As time goes by, what happens? More we're getting from. Clear? Any questions? No. All right. Let's move on to another question. Question 2 says, during the year from 2005 to 2011, just before, during, and immediately after the recession years of 2007 and 2009. So they took the amounts before 2007 and then after 2009 and during that period. So what happened? It says the number of single family houses sold decreased at a rate that can be modeled by an exponential function. Yes? So what do I expect the exponential function is going to look like for that particular rate? So if it was f of t or g of t or whatever, right? This exponential function should look like this. y0 e, now kt, correct? K in this case, because they said it was decreasing, correct? Then k would be simply what? Net. Yes? If I'm looking at a function, something like this, and that's going to be a b to the power t, yeah? And because it is decreasing, I should expect the value of b to be where? Between 0 and 1. Yes? Okay. Let's see what they found. It says the number of single-family houses sold can be approximated by the function g of x equal 1483, and they used e negative 0.28t. Yes? Or did I put x? If I put x, then this should be x. Whatever value I put here, that should be in the function. It says, where x equals 0 corresponds to the year 2005. So x equals 0 is year 2005. It says find the number of houses sold in 2008. So find number of houses sold in 2008. Well, we have a scenario, right? We are given an equation. First, let's see, is the equation complete? Do I have all the terms of the equation? I have the initial value, right? I have e to the only thing is missing is what? X, where x represent the year, correct? Okay, question here. How much houses were sold in 2005? I didn't say what year. I said how much houses were sold in 2005. 1,483, right? Remember, this value is always the initial value at time equal 0 or x equals 0 or whatever variable equal to 0. Yeah? So if 2005 is when x equals 0, so this value represent, and this function represent houses being sold. So that means the number of houses being sold in 2005 is 1483. Clear? All right, so now how do I find the number of houses were sold in 2008? And should that amount be more or less than 1483? Will be less because we have a decrease, right? And how do I find it then? So we need to figure out what x is. Yeah, what is x? So x equal, notice, we're looking at 2008, yes? We started counting from where? From 2005, where 2005 being 0, yes? So that's going to be 2008 minus 2005 equals. So in this case now, we can go ahead and simply substitute 3 in here, yeah? And figure out how many houses or how many thousands of houses were sold in 2008. So G of 8, I'm sorry, G of 3 equal 1483 E negative 0.28 times 3. And if we calculate that number, I think that will approximately comes out to be 640,000. So because the formula is in thousand, yes? Even though you get it 640, yes? But that number represents 640,000 because this is what the formula gives. How many thousands of houses were sold in a particular year? Now, question number 2, it says, what was the first full year in which the number of houses sold fell below 500,000? So we need to figure out the year at which the number of houses were sold were below 500. Now, we haven't learned how to solve exponential function yet. But here's what they're asking me for. They're asking me to find what x is when the houses sold were below the 500,000 house. Okay? So this is supposed to be done on a calculator. You guys have a calculator with you? No? All right. You'll probably need that. You need to learn. Hopefully I won't put any of those questions on the test, but if I did, I still have covered it. On your calculator, you would have a key says on top, it says y equal. Yeah? You press that key, and then functions come up. Or at least of several y1, y2, y3, whatever come up. Then you input that value. You input in the calculator that value. 1483 e to the power minus 0.28. How do I input x in the calculator? You find the alpha key. You press the alpha key. That represents all the green letters on your calculator. Yeah? And then you look where x is. You press that. After you do that, on the calculator itself, you have buttons on top. The last one says graph. Then you hit the graph button. And then you're going to get a graph that looks like this. Okay. On that, under the graph, underneath it, you have a few buttons. And one of them says trace. One of them says trace. So you click the trace button. Once you hit the trace button, it gives you two values. It gives you x value and it gives you y value. Equal. It will have some values over here. And then If this value is more than 500, you hit the right button. So you're moving the trace to the right. You keep moving it to the right until you get a value over here. The first value you get less than 500 or 500 or less. Yes? Once you get that value, you read x, and in this case, it'll give you x equal. Okay. This is how you do it on the calculator. Huh? Yes, we can find values for x. Yeah, we can find values for x, and we can make, now we already know at 3 is what? 640,000, yes? So if I want it to be below 500, do I move forward or backward? We need to move forward. So the next one would be maybe 4 to see how much it is getting down. Yeah? So I'll substitute 4 into the equation, into the x. And if I substitute 4, I believe I might get 483,000. That would be the next step you do. But yeah, you can look at it. You can make a table and look it up. Calculator will give you a table, right?
Because I don't use those calculators. I use like a really simple.
Yeah, I mean, I'm not going to worry about that on the test, but I'm just showing you how you do that just in case, because it's part of your book. So I'm going along with that. Yeah. Any questions? All right, let's move on. It said, when money is placed in a bank account that pays compound interest, the amount in the account grows exponentially. So they use exponential function to determine how much money you have in the account after you start depositing money, as we shall see in chapter 5. So that's the next chapter. Suppose such an account grows from $1,000 to $1,316 in 7 years. So you have an account. That account started at some time. You had $1,000 in it. Yeah? And in 7 years, you didn't do anything to the account. It was just simply collecting interest. Yeah? And in 7 years, now the account has 1,300, what did I say? $16. The question is, find a growth function of the form f of t equal y0 e to the power, is it e? No, they didn't say e, they say b. B to the power t, that gives the amount in the account as t years, as time goes by, yes? So now they're giving me some information from which I have to create my own formula. Yeah? Okay. Unfortunately, they didn't give me much information, did they? But I think they have given me enough to create my own formula. Otherwise, they wouldn't ask that question. How do I start with this? Well, two things. I need to know what do I need to create a formula, right? What you need in this particular problem to create a formula is to know two things. We need to know what y0 is, yeah? And we also need to know what b is. We have an idea what they are, but maybe we know b has to be a number bigger than 1, right? Why? Because the money is hopefully increasing, correct? Because you don't get a negative interest, you get positive interest, I guess. So in this case, we need to know those two terms. Once we know those two terms, then we can write the equation. What is y0 in this case? What does y0 represent in this case? Hmm? The 1,000, the initial amount of money you have. Yes? Now, even though they didn't tell me when I opened the account, I can assume the amount was open at the time I had $1,000 in it. So at T0, we had how much? 1,000. So in this case, Y0 equal 1,000. So now we know what Y0 is. We can write the equation using that. So f of t now equal 1,000 b to the power t. Now the only thing left for me to figure out is what b is. In order to figure out what b is, I need to know the amount of money I had at some time t. Yes? Do I have that? We do. What? We do know we had $1,316, right? At t equal how much? 7. Clear? So all I have to do is just substitute those numbers and solve the equation. So let's do that. 1,316 equal 1,000 b to the power 7. Yeah? To solve the equation, we need to isolate b. Okay? Well, we have 1,000 multiplied by that. So I can divide by 1,000. I can divide by 1,000. So now I can say b to the power 7 equal 1.316 after I've already divided. Yeah? How do I solve for b now? It would have been easy if it was b squared, right? Then we take square root. If it was b cubed, b to the power 3, I take a cube root. Yeah? If it was b to the power 4, I get fourth root. Yeah? So this is b to the power 7. So what do I do? Which root I take? Seventh. Yes? But what does that equal? What does that mean? In some calculator, you can find the seventh root. You can pick a root you want. But in some calculator, you can't. The other option for that is, this is the same thing as 1.316 to the power 1 over 7. Yes? Remember, we said if we have a to the power m, to the power n would be a to the power m times n. Correct? Remember that? Now, if I want to make the exponent here 1, I have to put b to the power 7, but I don't want b to the power 7. I want to make the exponent to be just simply 1. So what do I raise it to? So when I multiply these two, I get simply what? 1. Yes? Because I raise this side to 1 over 7, I can raise this side 1.316 1 over 7 as well. Yeah? So now we can say b equal 1.316 raised to the power 1 over 7. And with that, we get how much? Approximately 1.04. Yeah? So now we know B is 1.04. Yeah. So I'm getting 4% interest on my money. Okay? So now what is the formula? Now we know what Y0 is. We know what B is. The formula is f of t equal 1,000 times 1.04 to the power t, and that would be my formula for that particular problem. Yes. And those are some examples on how to use exponential growth and exponential decay. Yeah. Again, growth is getting bigger, decay getting smaller. Get to know how you can identify each one and do some example on those. Again, if you do have any questions on the homework that you're doing supposedly on my math lab, you can go ahead and bring them to class and we'll talk about it. Okay? All right. I think that's it for today. I'll see you back here on Wednesday. Huh? Wednesday. If you want to come. I mean, I'm not going to force you to say, you can watch online, you can watch in class, that's still okay. Because you can see. We are way below capacity. Don't worry about that. That's the only thing I worry about, is just the capacity. If we're below capacity, and even so it's not your turn, you can still come.